Welcome to this Yokogawa e-learning module. This module covers the digitalYEWFLO basic working principle. When you have completed this module, you should understand the following: Karman state, vortex shutting, Karman vortex frequency, Struhl number, structure, sensor, relationship of flow, force and output, K-factor. Summary. Now let's move on to the first topic. What is a Karman state? As fluid flows past an object in the flow, alternating Karman vortices are shed on the downstream side. Let's look at the working principle, starting with the vortex shedding phenomenon. A vortex meter comprises a meter body with a shedder bar in the flow stream. Karman vortices are generated at the edge of shedder bar when fluid passes across it. The Karman vortex generates a lift force on the shedder bar. The Vortex Flowmeter measures the flow rate by counting these vortices. This section explains the Karman vortex frequency. The Karman vortex frequency is proportional to the flow velocity. Therefore, it is possible to obtain the flow rate by measuring the Karman vortex frequency. F equals St times V by D is the mathematical equation, where F means Karman vortex frequency, St means Struhl number, V means flow velocity, and D means shedder bar width. What is the Struhl number? The Struhl number, St, is a dimensionless number which is a function of the shape and size of the vortex shedder. The Struhl number is the ratio between the vortex interval, I, and the shedder bar width, D. Usually the vortex interval is about 6 times the shedder bar width. When the Struhl number is fixed, the flow velocity can be measured by counting the number of vortices. And by selecting an appropriate shape of the shedder bar, the Struhl number can be kept constant over a wide range of Reynolds numbers. This graph shows the relationship between the Reynolds number and the Struhl number. Under a turbulent flow, when the Reynolds number is greater than 20,000, the Struhl number is constant. Therefore, vortex frequency is proportional to the flow velocity. But under transitional flow, when the Reynolds number is between 5,000 and 20,000, the Struhl number increases. Therefore, vortex frequency is not proportional to the flow velocity. Let's look at the structure of the vortex meter next. This cross-sectional view of the vortex meter shows its structure. A vortex flowmeter generally consists of a meter body, a shedder bar with a sensor, and converter electronics. Let's look at the sensor. Yokogawa uses a piezoelectric sensor to measure the vortex frequency. 2 piezoelectric sensors are embedded in the shedder bar and isolated from the process fluid. This construction and unique signal processing technology ensures stable measurement across a wide flow range. Let's examine the relationship of flow, force and output. Flow hits the shedder bar and separates, and due to the shape of the bar, forms vortices. The vortices create an alternating pressure differential across the bar. The shedder bar is physically stressed toward the low pressure side. A piezoelectric crystal converts these mechanical stresses to electrical pulses. The sensors are hermetically sealed and not in contact with the process. Fluid flows into the meter body and hits the shedder bar. Karman vortices are generated at the edge of the shedder bar. Karman vortex generates a lift force in the shedder bar. The stresses on the shutter bar are sensed by the piezoelectric sensors which generate an output signal. The signals from the piezo sensors are further processed by the amplifier. These signals are continuously generated by the alternating lift forces due to the Karman street effect. What is the K factor? The K factor of the Vortex Flowmeter is the number of pulses generated per unit volume. For example, let us consider 1 liter of fluid flowing into the Vortex Flowmeter. 3 vortices and 3 pulses are generated when 1 liter fluid flows through the meter. The K factor is calculated as shown. 1 liter. 3 pulses. The K factor is 3 pulses per liter. The K factor represents the flow characteristics of the Flowmeter. It is determined during factory calibration and also set in the parameters. It is also indicated on the instrument nameplate. Let us now summarize what we have learned in this module. Summary. The Vortex Flowmeter counts Karman vortices. The Karman vortex frequency is proportional to flow velocity. Karman vortex frequency, F, equals the Struhl number, St, times flow velocity, V, over shutter bar width, D. The Struhl number, St, equals shutter bar width, D, over vortex interval, I. K factor equals number of pulses by unit volume. This concludes our module on the basic working principle for digitalYEWFLO Vortex Flowmeters. For more information or to contact us, please visit our website and official channel on YouTube. Thank you.